Good morning, students. Today I am explaining two-phase method. So in simplex method and big M method, I explained maximization problems. Now I am explaining minimization problem. So minimize z equals to 12x1 plus 20x2 subject to the constraint 6x1 plus 8x2 greater than or equals to 100 and 7x1 plus 12x2 greater than or equals to 120, and non-negativity restrictions means variables x1 x2 always greater than or equals to 0. So as usual, first you have to verify the given objective function is minimization or maximization. At present situation, the given LPP is minimization, so we have to convert it into maximization by using the relation minimum z equals to minus of max minus z. That implies minus maximum of, what is our z? 12 minus 12x1 minus 20x2. So that implies it becomes, therefore, so you are doing the problem with the maximization. So max minus z equals to, finally what you are getting, minus 12x1 minus 20x2. So this is the way, this is the procedure how to convert the minimization problem into maximization. See the relation minimum z equals to minus of max minus z. So what is our z? 12x1. Both the variables are having the positive sign. So minus max z. So the z value you have to multiply with the minus. So minus 12x1 minus 20x2. So now you have to consider maximum of minus z equals to minus 12x1 minus 20x2, and then verify all the BAs are non-negative. Yes, all the BAs are non-negative, so no need to convert. And then move to the third condition by converting the given inequalities or inequations into equations by introducing either slack or surplus or artificial variable. So if you observe here, both the constraints are greater than or equals to type, so we have to introduce surplus variables along with artificial variable for getting the IBFS. So that implies 6x1 plus 8x2 minus s1 plus a1 equals to 100. The second one, 7x1 plus 12x2 minus s2 plus a2 equals to 120. Here s1 s2 are surplus variable, a1 a2 are artificial variables. Then the modified objective function is, as usual, minus z equals to, here we are having minus z equals to minus 12x1 minus 20x2 plus 0s1 plus 0s2 plus a1 plus, in the objective function it becomes negative, minus a1 minus a2. But in the case of big M method, we are using the penalty minus m minus m. But this is two-phase method, that's why no need to take the penalty m. So but in the place of m, you are writing as usual minus a1 minus a2. Then the matrix form. The matrix form of LPP. LPP is 6, 8, 7, 12. Here S1 is available, so write down minus 1. S2 0. From the second equation, S1 is unavailable, so S2 is available. But it is not IBFS. This is called IBFS. IBFS always means identity matrix should always with the positive sign. Here you are not getting IBFS. That's why you are introducing artificial variables. So 1, 0, 0, 1. And what are the variables are available in our constraints? x1, x2, s1, s2, a1, a2. And the BIs are 100, 120. So this is A x b. Therefore, xb equals to b inverse b. That means the initial basic feasible solution is it implies A1, A2, 100, 120. So in that name only we are having two-phase method. So that's why you have to solve this problem with the two phases. So now I am taking phase 1. In phase 1, a small change, that is auxiliary LPP. So whatever we mention the modified objective function, instead of that we have to take Z star. So Z star and the remaining whatever the coefficients in the objective function, that all the coefficients should become 0 except artificial variables. So that's why auxiliary LPP. With the help of auxiliary LPP we have to solve the phase 1. So z are equals to minus a1 minus a2. So as usual first iteration, basic variable cb, xb, x1, x2, s1, s2, a1, a2 and minimum ratio. So basic variables, what you have to take, whatever you wrote that you have to consider in the basic variable and write down the coefficients of all the variables. X1 0 because we don't have any x1 x2 in the auxiliary LPP, that you have to consider in phase 1. So minus 1 minus 1, but in the case of big M method you have to take minus m minus m. That is only the difference between big M and two-phase method. In the CB you have to take minus 1 minus 1. In the place of XB you have to consider 100, 120 and express as it is the matrix 6, 8, 7, 12, minus 1, 0, 0, minus 1, 1, 0, 0, 1. And z equals to multiply minus 1 into 100, minus 100, minus 1 into 120, minus 120. So that is minus 100 minus 120 is minus 220 and immediately you have to find the net evaluation, that is delta z. As usual, minus 1 into 6, minus 6, minus 1 into 7, minus 7, minus 0. So minus 6 minus 7 is minus 13, minus 6 and minus 7, minus 13 and then minus 1 into 8, minus 8, minus 1 into 12, minus 12 plus 8, minus 12 minus 8, that is minus 20. Minus 1 into 1, it is 0, so no need to consider. Minus 1 into 1, both are minus into minus becomes plus 1. So minus 1 into 1, 1, minus of minus, it becomes 0. Both the terms becomes 0. The next step, the next iteration, move to the next iteration. First you have to verify all the delta j's are positive or not. No, two values are non-positive, that is negative value. So among these two, which is the most negative? Minus 20 is the most negative, that is the incoming vector. So then immediately move to the xb by xk, that is minimum ratio. Xb value is 100 by 8 and 120 by 12, that is 10. 100 by 8 value. So 12 point something. So among these two, which is the minimum? 10 is the minimum. So this is called outgoing vector corresponding this. So which one is take out? A2 is removed from the basis matrix. A1 as it is in the place of A2, what you have to consider? X2. So a1 x2. So x2 0, a1 minus 1. So the key element should, what is the key element here? 12 is the key element, but key element should always be 1. But here you don't have that 1. So that's why you have to apply row operation this entire row, and the above value should become 0. So then how it will work? See. So that's why for getting 1, so you have to divide this value, this element, by 12. Not only this element, this entire row. That's why 120 by 12 means 10 minus 1 by 12, 1, 0, minus 1 by 12. So a2 is removed from the table. That's why no need to do the a2 values. So you can do up to a1. And then the above value should, now you are getting the key element become 1. Now the second step is this 8 should be 0. So always key element is R1. So the second one is R2. For getting R2, R2 tends to R2 minus 8 R1. R2 minus 8 R1. What is R2? This is the R2. R1 is, so you have to multiply this with this 8. This one with 8. 8 tens are 80. And 8 by 12, 8. So then you will get 100 minus 80 is 20. So after simplification you will get here 4 by 3. So here 8. So 8 minus 8, 0. Minus 1, 0. Minus 1. So plus 1 by 12. 12, and this value is 1. Minus 1, here I am multiplying with 8. So 0 minus 8 by 12. 0 minus 8 by 12. 2 4s are 2 6 are 2 2s are 3. So that is, you will get here 2 by 3. 2 by 3. Why you are getting 2 by 3 means you have to multiply this row with 8. So that is 8 by 12. So after simplification you will get 2 by 3. And as usual find out z. Z equals to minus 1 into 20. Minus 20, and delta z values. 0 means you can ignore that. Minus 1 into 4 by 3. Minus 4 by 3. Minus 1 into 4 by 3, minus 4 by 3, minus 0, you will get minus 1 by 3 only. Minus 1 into 0, 0. Minus 1 into 0, 0, minus 0, 0. Minus 1 into minus plus 1, 1 are 1. Minus 1 into 2 by 3, minus 2 by 3. Minus 1 into 1, 0. Again you are getting 1. Both two negative values, minus 4 by 3, minus 2 by 3. So this is the incoming vector. So 20 by 1 into 3 by 4, 10 by 1. So it is a negative, so no need to consider. It is a negative value, so no need to do it. So here 20 by 1 into 4, 4 5s are 5 3s are 4 5s are 20, 5 3s are 15. So this is the outgoing vector. So here the key element is, and the key element is 4 by 3. Then you can remove by observing here the outgoing vector is corresponding to a1. So you can eliminate the a1. In that place you have to introduce x1 because the incoming vector is corresponding to x1. So finally you are getting x1, x2. So 0, 0. So 4 by 3 means whatever you got that it will be appear here itself. 4 by 3 it should become 1. So you have to multiply this entire row with 3 by 4. So then it becomes 1, 0, minus 3 by 4. So 2 by 3 into 3 by 4. 3 3 cancel. 2 by 4 means 1 by 2. And a1 is eliminated from the matrix, from the basis. So no need to do any calculation for that. And the below value should become 0. So below value should become 0. So then how to get that become 0? So then this is the R1, R2 is, so here the value is available minus 1 by 12, but here the value is 1. So first write down 10 minus 1 by 12, 1, 0, minus 1 by 12. So then you have to multiply the key element with 1 by 12. So 15 by 12, 1 by 12, 0, minus 3 by 4 into 1 by 12. So that is 3 4 4 3 4 0 so minus 1 by 16, and here the value is 1 by 2. So 1 by 2 into 1 by 12, that is 1 by 24. Here the sign is minus, so that's why you have to take the row operation. R2 tends to R2 plus R1, R2 plus R1 by 12. So plus minus, sorry, plus plus. So both are gets cancelled. 1 minus 1 by 16. So 10 plus 10 by 1 plus 15 by 12. So finally you will get 15, 5 by 4, this value becomes 0, 1, 7 by 16.